Our next segment is going to be As the Prop Turns. Don Mccrae from Frank and Jimmie's has been generous with his time to come and talk to us about propellers. Don brings a background in production operations management from General Motors, US West, PepsiCo, to his new role as president and COO at Frank and Jimmie's. He's a certified project management professional. Don's a former project manager and operations director at Rybovich, not Rob the Rich, Rybovich, in West Palm Beach, and served as a captain and engineer aboard a yacht in the Mediterranean and Virgin Islands. Don Mccrae.
Thank you, Paul. I had one joke and you took it, so I'm not quite sure. I'm not quite sure where to go from there. As the prop turns, my name is Don Mccrae, and I'm the president and COO at Frank and Jimmie's. And like most of you, I'm sure, I've been a recreational boater all my life, although I'm not sure that counts for much because I'm born and raised in Michigan, so the boating season's only about 3.5 months a year there. So my cumulative knowledge isn't that great. But when I came to Frank and Jimmie's as the first time I really figured out how much I did not know about propellers. We take propellers for advantage and for granted, like the tires on our car. We never really think about them, like electricity or how the internet works. We never really think about it until the electricity goes out or the internet's down. And then you start to wonder, how does the internet get to my house? And how do I get that information from Google? So my purpose this afternoon in sharing a little thoughts with you is not to be overly technical. In fact, I couldn't possibly be overly technical. But to share with you some thoughts about propellers and the yachts so that you can better serve your clients and customers, the owners and captains of the boats, and share with them some thoughts that would put you in a better position to advise them and be part of their trusted management team on board those vessels. As we know, yachts are very sophisticated, very complicated systems. Many things can go wrong on a yacht. The hot tub doesn't work or the wine cooler doesn't work. You can still have your charter. If you have a problem with the props, that yacht is not going anywhere. So let's see if we can talk a little bit about this. Frank and Jimmie, 1947. We've been in business for 70 years. We operate out of a 10,000 square foot facility in downtown Fort Lauderdale. And Frank and Jimmie's is known for its highest accuracy, best pricing, on-time deliveries, and most importantly, providing strong engineering and technical support. We really do want to partner with the captains, owners, vessel managers of these yachts to make sure that they're getting everything that they need to get out of the performance of their yacht and their propellers. Yacht design has changed tremendously in the last 30 years. Prior to about 30 years ago, propellers were standard, kind of off-the-shelf, one design, constant pitch propellers. But in the last 30 years or so, we're starting to see propellers that we've never seen before. And it's almost every day that we see something new coming into our shop that we've never seen before, and we have to work on repair, recondition, repitch, something of that nature. Quick overview. A marine propeller produces thrust the same way an airplane wing produces lift. So you may remember 7th, 8th, 9th grade physics class little movie, airfoil flow over the top and over the bottom of the propeller. Differences in pressure move the airfoil up. So a propeller operates the same way. It is a rotating airfoil or a rotating wing. There's only 3 things really you need to know to describe a propeller and to have an intelligent conversation with anyone about a propeller. The diameter and the pitch, which is expressed as 2 numbers, 48 by 48, we would call that a square propeller, 48 squared. The diameter first, 48 inches, the pitch, 48 inches. We'll talk about that in a second. The third thing is the number of the blades. With those 3 pieces of information, diameter, pitch, and number of blades, you can have an intelligent conversation with 90% of the people about what you need to do with your propeller. The 4th characteristic up there, blade area, really is not a common conversation for a person beyond the designer or the engineer or perhaps the salesman that is looking to put you into a different blade propeller area. So diameter, pitch, number of blades. So first question that I have for you is, what's more important of those 3? What's the relationship between diameter, pitch, number of blades? Pitch, okay. Pitch, diameter, number of blades, we have a pitch. All right, I think pitch might be a good answer. We'll see as we go along here. The second question I have for you is, when dealing with number of blades of propeller, which is a more efficient propeller? A propeller with fewer blades or a propeller with more blades? Fewer, more, fewer. Where's the it depends guy? All right, it depends. We'll get to that as well. If I had asked this question 30 years ago, what would the answer be? Fewer, absolutely, fewer. If I'd asked the question 30 years ago, fewer. Now, today, complex propeller design, complex blade geometry, you can actually have propellers with more blades being more efficient and in some cases faster than propellers with fewer blades. Okay, the first thing you need to know about, remember we said diameter and pitch. So diameter, pretty obvious, the diameter of the circle of the propeller. The pitch is the distance that the propeller travels in one revolution through a soft solid. We like to say put your propeller down on a big tub of Jell-O, screw it around one time. However far it moves down through that tub of Jell-O, that's the pitch of the propeller. So a 24-inch propeller will screw down into the Jell-O 24 inches. In water, because it's not a consistent medium, it's not the same, but theoretically, in a soft solid, that's your pitch. Okay, diameter and pitch considerations. Power, RPMs, the gear reduction ratio, and the vessel size and application. So what is the relationship between power, RPMs, and pitch? Straight relationship, inverse relationship, no relationship? Straight relationship. So if you have lots of power, do you want lots of pitch? Little pitch. It depends. Another it depends answer. Very good. All right, so we're going to talk about this in a little bit, and we'll see what are the considerations that we need to take into account when choosing the correct pitch for our propeller. Gear reduction ratio, again, determines going from the engine through the transmission, through the running gear, back to the propeller, what we're going to see in propeller speeds and RPMs. And then finally, vessel size and application. You're running a trawler, we're going to need bigger propeller, lower pitch, and a tug, versus a high-speed yacht, smaller propeller, relatively speaking, higher pitch. So generally speaking, higher pitch, higher speeds, lower pitch, lower torque. Just like the gear reduction or the gears on your car, or think about a 10-speed bike. You're driving a 10-speed bike up a hill, what do you need? Low gears. You want to go fast down the other side, high gears. All right, very good. Blades and blade area. Again, now you're getting into a conversation that is really beyond what you need to have with even the highest professional yachtsmen. This is more for the engineers and the salespeople. But one thing to know, blade loading creates tip vortex and induces drag. So going back to our high school movie of the airplane, remember when the two flows come back together on the other side of the airfoil, the winds get turbulent, they get mixed, and they create a big messy stream of air. That's what we're talking about there. So increasing the number of blades decreases the load per blade. This is the conversation. 30 years ago, fewer blades, more efficient propeller. Now, having a larger number of blades reduces the load per blade. Very simply seen here, take the total thrust, divide by the number of blades, you have less thrust per blade, which means you can build a propeller now that's thinner, lighter, and again can be more efficient, and you're distributing those turbulent air flows, or in this case water flows, over more area, more propeller blades to reduce the effects of drag and inefficiency. All right, 30 years ago, again, most propellers came from a foundry. Now today, most propellers are CNC machined. They come from foundry as a blank, an extra thick propeller, and then they're CNC machined. So this allows for customization and allows for a much more efficient manufacturing process and a much less expensive manufacturing process. Now you can get Class 1 and Class S propellers, which we'll talk about in a moment, right from the manufacturer at a very reasonable price. Skewed propellers. Most of the propeller design in the last 30 years, most of the advent and research has been done in two areas: to create a more efficient propeller and to create a propeller that doesn't vibrate, a propeller that doesn't create noise, a propeller that runs smoother. So in this case, skewed propellers, by skewing those blades back, skewing the trailing edges of the propellers back, you're reducing those vortices of the turbulence coming off the blades, and that makes for a smoother running, smoother performing propeller. The Capel Propellers. This was a revolutionary design, started out in the late 70s, took 25 years for Capel, a naval architect, to perfect this design, but perhaps the most revolutionary design in the industry in the last 50 years. Interestingly enough, Capel started out as a naval architect and a ship designer. During the 70s, when there was a move to containerize shipping, the ship owners wanted single engine, single screw vessels to transport their containers for ease and cheaper operating, build, and maintenance costs. And Capel realized that putting that much, and the other thing was they wanted an operating speed of 26 knots in the late 70s. So Capel realized that creating those kind of forces were going to create tremendous amount of turbulence on the hull and the wake, and put a lot of pressure at the aft end of the vessel on the running gear, the rudders, the propellers, and subsequently create a lot of vibration in the vessel itself. So he started out working on the design of the stern of the vessel, and now when you see a modern, not a square end, but you see vessels of that era that have the tapered, almost the canoe end on a big ocean-going transport vessel, that was the result of his work. He then took that to the next step and took it to propellers and designed this propeller. Again, like the next slide we see here, the square-tipped propellers, they all are designed to do one thing and one thing only: reduce vibration, which reduces noise. And where are the sailors in the room? Do we have some sailors? I'm actually a sailor. Don't be ashamed. Don't be ashamed. The sailors. So when I was sailing, we said nothing goes to windward like a G4. All right. So if you look here, it's the exact same theory. The wingtips reduce the turbulent flow coming off the trailing edge of the wing or off of the propeller blade, and that gives you a more smoothing performing propeller. Costs, very important. If you're getting involved, if you're a buy-side broker and you're having a conversation with a client about, we're going to buy this vessel, this yacht, but we're going to change out the propellers, what are the costs involved? For a standard off-the-shelf propeller, square, flat, constant pitch, a traditional propeller, you're going to pay a base rate. For semi-custom, 15 to 25%, and for a full custom propeller, another 25% on top of that. So full custom propellers are usually designed with the boat when the boat is in the design and build stages for the mega yachts that we're seeing today. Most propellers we see now, semi-custom, where they start with an off-the-shelf design, semi-custom for a wide range of applications that then can be dialed in a little more appropriately for what they're looking for. There's a picture of our shop and a skewed propeller there on the dynamic balancer, and we'll talk about balancing in a moment and why that's important. So at Frank and Jimmie's, our 4 top business mix. The reason why propellers come to us: damaged propellers, number 1 by far and away, damaged propellers. And as I said at the beginning of my conversation, if you're the trusted advisor of a vessel owner or a vessel captain and the propellers are damaged, that boat's going nowhere. And depending on how those propellers got damaged, somebody's in a world of hurt or somebody's in a panic. So that's our number 1 source of business. Beyond that, vibration, number 2, we're going to talk about that. Then looking to increase performance, and then finally building spares for the boat owner that has that in mind. We'll talk about that as well. Again, 30 years ago, propellers were mostly done on pitch blocks. Now we use an MRI or a prop scan machine that are basically coordinate measuring machines. You can see here the prop scan technology, computer in the background, an arm and a stylus that comes down, and we can basically measure an infinite number of points in space. And what we're looking to do is make sure every propeller blade matches every other propeller blade. It would be ideal to take those propeller blades back to their original tolerances, but that's often not possible. We'll talk about that a little more towards the end of my presentation about how we deal with that. But it's like if you're a chef and you make something from a recipe, but you don't follow the recipe exactly and you add a little extra of this or you take a little bit of that out. If you don't write that down, you don't document what you did, you're never going to be able to create that dish the exact same way again. So when we have damaged propellers coming into the shop, the only way in most cases we can make those propeller blades consistent is by comparing the damaged blades to an undamaged blade. If that undamaged blade has previously been repaired or previously been reconditioned, we're kind of winking in the dark. Without the original design files of the propeller, we don't know where to start. We like to say now that propeller repair technology is where the space age meets the Stone Age. So I had a friend come and tour the shop not too long ago. I took him through the shop. After the tour, he said to me, "Oh, I get it. You measure them on a computer and then you hit it with a rock." It's exactly what we do. Here, one of our technicians, Sal, a very senior man in the industry, is measuring the propeller, laying it out. You can see the computer in the background. But next thing he's going to do is basically hit it with a rock. All right, we put it on a stand. We might heat it up, but we're going to hit it with a rock. And there's our various rocks, all different kinds of rocks. So it is where the space age meets the Stone Age. Many people think that the computer itself reconditions the propeller. That is not the case. It's good old American labor and ingenuity and know-how. Class tolerances. Class 3, 2, 1, and S. Wide and medium tolerances usually used for work boats where vibration is accepted and tolerated. Class 1 for performance in the recreational pleasure boating market. And Class S, very high tolerances when you want to ensure that the vibration that's coming from the vessel or from the running gear is not due to imbalance or out of balance of the propeller. Class S is the tightest tolerances, and that will ensure if the propeller is reconditioned to Class S, then the propeller is not going to be the source of the vibration. Pitch tolerances. Just taking a look at here, these all come from ISO standards. It's important to note, again, when you're advising your customers, your clients, the ISO standards used in repair and reconditioning of propellers, in the industry, we've basically stolen them from the manufacturers. So the ISO tolerances are for the manufacturing of propellers. There are no ISO tolerances for the repair and reconditioning of propellers, but the local propeller shops have taken those tolerances and adapted them for our needs. So the big thing to notice here for propeller pitch at Class S, plus or minus 0.5%, where for Class 3 it's plus or minus 3%. Law of diminishing returns. During World War II, the Navy started repairing and reconditioning propellers on their ships rather than replacing them because of the time and expense involved. And they found there was a very definite law of diminishing returns for repairing propellers. And the big controlling factor here, how good is good enough, comes down to how much time you want to invest in the process. For the U.S. Navy, money wasn't a factor. For the rest of us, it is. Time does equal money, so I've made a footnote there. Just to go from Class 1 to Class S adds another 37.5% to the cost. It's quite significant. But you can see the law of diminishing returns and the improvements you get in speed and vibration. Here's an example of a typical propeller. This looks to be about a 30-inch propeller or so. Not quite sure what happened there. I can't speak for the full 70-year history of Frank and Jimmie's, but in the 2 years that I've been at Frank and Jimmie's, no one's ever fessed up to how a propeller ever actually got damaged. So the number one cause seems to be heavy water. We hit some heavy water. So this would be typical to heavy repair required of a propeller. And I'm just showing you a top view there of what it looks like. You can see all the edges curled over. out towards the outside radius of the blades. You can see some chunks of propeller missing. That's a fairly typical propeller repair for us. You can see here the propeller has started to be repaired. The technicians cut away the areas that have been broken, and what happens is they have to be welded back on. So we don't weld a new piece onto a missing piece, but the weld has to be built up, one row, one bead at a time. So that's why it's a very laborious process. And there's the final, what that propeller looks like repaired before it goes into the grinding and finishing room. Geometric consistency, the number one reason, the most important thing to do to repair your propellers is have the propellers be geometrically consistent from blade to blade. The second thing is to balance the propellers. So just like when you get new tires on your car, they're balanced. We do the exact same thing with propellers. We static balance all of our propellers, and for about 70% of the propellers that come into the shop, this is good enough. And static balance just means we put the propeller on an arbor, basically a prop shaft, on rollers, and move the propeller and take weight off the propeller by grinding until that propeller will stay in a fixed static position. That's good for about 60 to 70% of the cases. For all Class S propellers and for propellers that have been through extensive damage repair that have had a lot of weight added to them through welding, we will dynamically balance the propeller just like I showed in an earlier picture and just like when you get your tires balanced. So static balance measures the balance of the propeller in one plane from the top to the bottom. Dynamic balance also measures and corrects for the wobble from side to side of the propeller. And there's dynamic balancing in operation, spinning a propeller maybe 200 or 300 RPM, sensors on the machine report the wobble, and then we sand off on the back side of the propeller the appropriate weight. At Frank & Jimmie's we have a production schedule. We're going to talk about this later. One of the things I just want to point out, average amount of times for repairing a propeller's 5, 6, 7 days. The best you can get, 4 days if you make an advance reservation. Here's one of the ways that could help you with your customers. If they're getting hauled out, they have to plan that in advance. If they think they're going to have their propellers checked, cleaned, balanced, reconditioned, schedule that with a prop shop. Doesn't have to be us. Schedule that in advance with the prop shop. Advanced scheduling, you can get it in 4 days. Severely damaged propellers, 12 days. The best turnaround time we offer is 3 days for an expedited repair. We'll talk about that in a moment too, but that costs a lot. So plan in advance. All right, let's talk about vibration. Why is vibration important? Number one reason is because, exactly, who said that, right? Billionaire yacht owners don't like their martinis sloshing around during cocktail hour. So vibration, it's very annoying and it's very troublesome, like that little mosquito that's buzzing in your ear as you're trying to fall asleep at night. Vibration is the death knell on a boat. Right, Rich? You paying attention?
Yeah, you're singing like too.
Okay, all right, good. Vibration. So very, very common causes of vibration. Notice I've listed damage to propellers at the bottom. It's always easy to point to the propellers as the source of vibration. Frequently, it is not. Now, we're perfectly happy and fine if you think it is, and you bring your propellers to us. No problem. We'll check them out. We'll check them out for free. We'll balance them. But there's a lot of other systems in play that can lead to vibration. The propulsion system, the hull noise, cavitation, and the propeller taper and fit. Propulsion system vibration just occurs because you've got a lot of moving parts at a lot of different RPMs and a lot of different frequencies. Frequently, they can resonate and cause vibration throughout the vessel. Hull noise and vibration, turbulence from the prop interacting with the hull, again at certain frequencies, can create vibration throughout the vessel. And cavitation creates vibration and damage to props throughout the vessel. Cavitation, again, we talked about the airfoil surface of the wing. Cavitation is basically in a low pressure area, water turns to vapor. When that water vapor leaves the low pressure area as it's traveling aft of the vessel. When that water vapor starts to reconstitute itself back into a droplet of water, it hits the surface with tremendous force, like water jetting. And that can cause not only tremendous amount of noise, but damage to the propellers. One of the ways we deal with that is by welding on cavitation bumps right into the propellers in the area of where the damage has occurred. So again, if you're managing a vessel where they're complaining of cavitation, this is a possible solution. Propeller fit. If the propeller is not fit squarely on the shaft, you're going to have vibration. How many have ever been to the dentist and had their bite checked? All right, we do the same thing with propeller fit. We blue fit the propeller to the shaft taper, and if it's not perfect, we'll lap the propeller onto the shaft taper. Here's a good one. Here's one. You're reviewing a vessel on the hard with a potential buyer. You see the propellers. You see in the upper right-hand corner, you've got the jam nut, which is the thinner nut, followed by the thicker nut. And in the bottom picture, you have the thicker nut on first, followed by the thinner nut. Which is correct? The bottom one? Why is that correct? Because it looks better, right? Symmetrical. All right. The top one is correct. All right. We call the thinner nut the jam nut. We see this all the time. The thinner nut is the jam nut. That goes on the shaft taper first. That gets screwed down and torqued onto the propeller hub first. Then the thick nut goes on after it and is torqued down. And what happens when you torque down that thicker nut? You're transferring the load from the jam nut to the larger nut. The larger nut has many more threads to absorb that load. So that's the theory there. So when you're on the hard, you're looking at boats in the yard, you see that. Doesn't necessarily mean anything's wrong, but it's an observation you can make that that propeller has been installed incorrectly. Incidentally, here's a question. What's the number one cause of loose propellers or loose nuts? Why do the nuts get loose? I'm sorry?
Keys missing?
Nope, the keys, incidentally, the key is not required to hold the propeller in relationship to the shaft. The key is the backup. The propeller should stay on the shaft if it's correctly installed with the taper. If there's a 75% match between the taper and the propeller hub, there's enough friction and enough thrust created by the vessel moving through the water that the propeller will not spin independent of the shaft. The key is a backup. Yes, the key is a bit.
It won't spin. Huh?
Correct. There should be a 75% match in the blue fit between the hub and the taper, but the propeller will not spin on the shaft. The key is a backup. If you don't have that, then you're relying on the key to absorb all of that torque, and that's going to lead either to a broken key or a cracked keyway. So, the question, so why do the nuts come loose? Why do we have a problem with loose nuts? It's usually because the fit of the propeller hub to the taper is incorrect, and the propeller is riding up on the taper, so the propeller has moved. That's why the nuts are loose. The nuts didn't back off, the propeller moved forward, and the nuts are loose. So again, you're having a conversation with your captain. Oh, I'm having a tremendous problem with loose nuts. The nuts are always coming loose on the shaft. The reason why is the taper probably is incorrect. The propeller is moving up on the shaft. Okay, we talked about this earlier. The relationship between pitch and/or diameter and RPMs. An inverse relationship. You want more RPMs, you want to take the pitch down. You want fewer RPMs, you want to take the pitch up. Same thing with diameter. Our rule of thumb, if you're looking to adjust RPMs more than 10%, make sure you check the sizing of the propeller. Is the propeller of the appropriate size, diameter, and blade area for that vessel, for that application? The maximum propeller repitch that we advise is 10%. So we do a lot of repitching of propellers, especially during this time when boats change hands. When the boats go through the sales process, we get a lot of propellers in for repair, reconditioning, or performance improvement. So this is another good conversation to be educated about. Propensity, the tendency of a vessel to hit a reef or other obstruction during sea trial, thereby damaging the props immediately after purchase, repair, or reconditioning. We get a lot of propellers in on Monday that we sent out on Friday. Happens all the time. As I was preparing for this presentation, I thought, where it says immediately after purchase, I thought this could also apply to the purchase of the vessel. This is very common, very, very common. The vessel changes hands, you have a new crew come on, you have a new captain come on, he or she may be cruising in unfamiliar waters. The next thing you know, the new owner has spent a considerable sum of money on a new boat, he's got his first charter planned, and he's got damaged props. So that becomes a problem. And we'll talk about that, how to deal with that. And that is, weekends last longer when you carry a spare. And so do captains' careers. Going back to the opening conversations, propellers at this level, mega yachts in Southeast Florida, most of these propellers are custom. 8 to 12 weeks minimum to get a replacement propeller from the foundry. That's if you have the original design specification and engineering drawings, and if the propellers have not been modified in the past. If you don't have the drawings and the propellers have already been repaired or reconditioned, you have to start over from scratch. So spares are the way to go. And the second thing that you can advise your captains and owners on is keep good records. When we repair and recondition propellers, here's a scan showing the different blades down the left side and the different radius along the top and the actual points in space that we've measured on that propeller. We save these reports, we send them out with the reports to the vessel. If your captain's not keeping them, maybe you should keep them for him or her as part of your management function. That way, if there's damage to the propeller, maybe they're on the other side of the world, you've got the information that you know. The recipe, this is the recipe for the propeller to bring that propeller back to its previous condition. Again, final report showing you the tight tolerances of all the points on the blades. All right, these are the things we hear all the time at Frank and Jimmie's from captains in order of various states of panic. My propellers are damaged and I have guests flying in this weekend. Please help. The next one is, I'm going to have to cancel my charter if you please don't help. We just bought the boat. We hear this all the time. We just bought the boat. The boat is not performing the way we expect it to. Vibration or other problems. And again, new boat means lots of use early in the life of that owner's time, so they want to use the boat. We need help. Then it becomes the owner's flying in this weekend, quickly followed by, if you don't help us, we're going to lose our job. And then I'll pay extra, I'll pay anything. This is my favorite one. Do you know why it's my favorite one? Not because I'm going to make a lot of money, which is nice.
The boss is going to pay, right?
The boss has got to pay. This is my favorite one because this implies that I am in fact Superman and I can fly backwards around the earth fast enough to turn back time. Because I don't know your definition of paying anything, but I don't know anyone that has enough money that can change 8 to 12 weeks to get a propeller from the foundry. I haven't seen it yet. So if you don't have spare propellers, paying anything is not going to help you out of this predicament. And let's be truthful, some of our owners, some of these vessel owners are accustomed to being able to pay anything and to get what they want. And when that's not possible, they tend to get a little upset. And then finally, after all of this happens, we usually get a call a couple weeks later. I put this in smaller type, I'll read it to you. Sometimes it comes from the captain, sometimes it comes from the broker. It says, I sold my boat, and I've got some spare props I forgot about in a storage unit. Would you like to buy them from us? Sure, I'm going to buy them from you and sell them to the guy you sold the boat to. Another little, I think, tidbit for the buying and selling yacht brokers in the room. If you're buying a vessel, please ask if they have spare propellers. That should be part of the deal. All right? They're sitting in a storage unit somewhere, like when you buy a house. the fixtures on the wall come with. So if you're a buying broker, please ask, are there spare props? If you're a selling broker, that could be a nice way to get the deal closed, right? We have spare props sitting in crates in Fort Lauderdale. They can be flown anywhere in the world in 48 hours. That's a positive, especially if they're big, custom propellers. That's the right answer. I'm not trying to sell more propellers. If the propellers get damaged, they're going to come to me anyhow. We're going to repair them, or we're going to sell new ones, but it's a lot cheaper for the vessel owner to have the spares ready than to have to get them, again, before the guests are flying in or the owner's charter or anything of that nature. Okay, so here's the summary. What you need to know as a buying or selling broker or vessel manager to have intelligent conversations with your customers about propellers. And I actually have handouts of this for you, so you don't even have to write it down. So the first thing you need to know, propellers suck. All right, we didn't talk about that. That was going to be my first question. I forgot it. Do propellers, everyone wants to know, how do propellers work? Do they pull the boat through the water, or do they push the boat through the water? They pull. That's right, exactly. Very good. So propellers suck, all right? For you sailors, the wind blows, and for the power boaters, propellers suck. So the forward side of the blade is the suction side and the low pressure side of the blade. The back side of the blade is the pressure and high pressure side of the propeller. Diameter, pitch, and number of blades function in a reverse relationship. You want more of one, you have to give up a little of the other. The old rule, 1 inch equals 200 RPMs. Again, 30 years ago, you could adjust the propellers by 1 inch and gain 200 RPMs. That doesn't apply so much anymore with complex geometry propellers. The new rule is you want to improve RPMs or performance by 10%, just take 10% out of the pitch. Number of blades versus efficiency and loading. Again, the old rule, fewer blades, more efficient propeller. The new rule is maybe, not necessarily so. Show some class, all right? Have your propellers repaired and reconditioned to class. Understand what you're getting for various levels of class performance. Geometric consistency and balance, the two most important things in propeller performance. And remember, you have to, let me get on to it, keep good records, all right? The records are the recipe for the propeller. So if the propeller's been reconditioned, keep those records, because that's the only way to get that propeller back to that same level of performance again. And what we see is even with custom propellers on new builds, those propellers might come into the shop 2 or 3 times over the course of 2 years during 2 or 3 yard periods, because they're continually tweaking those propellers. There's a little resonant frequency that's set up somewhere in the vessel, right, Rich? And at a certain RPM, the wine glasses are vibrating, and they want that gone. And they get those propellers just tweaked in just the way they want them, and then they damage the propellers. The only way to get those propellers back to where they were is if you have the records, the recipe for the propeller. Advance schedule your check, clean, and balance when you schedule your haul out. Again, you're advising your captains, your owners, hey, the boat's coming out in 3 months. Let's make a reservation right now with our favorite propeller shop to get those propellers checked. It's efficient, it's easy, and it's inexpensive. And finally, weekends last longer when you carry a spare. So do captains' careers, and maybe yacht brokers too. Thank you.
Thank you very much. Thank you.